Hello everyone. In this video, we'll understand matrix multiplication. Basically, a matrix is a two-dimensional array which is written in form of rows and columns. So we have this particular matrix has 3 rows and 3 columns. So this is 0th row, this is 0th column, first column, second column, 0th row, first row and second row. Okay, so as there are indices for a one-dimensional array, in case of two-dimensional array, there are two indices with respect to rows and column. So 0 has index of 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. Okay, so this element 4, it has index 1, 1. So what does this mean? 4 is present at first row and first column, right? So what about 5? 5 has the index of 1 and 2, which means first row and second column. So you have to remember one thing: the elements of an array are stored row wise. Okay, so first row is filled, next row is filled, and then the last row, right? Again, I have discussed more about the matrix in my arrays video. Have a look at it. Okay, now in this particular program we are supposed to perform 4 tasks. One is to read the size of 2 matrices and check the compatibility for multiplication. Second, to print appropriate message if the condition is not satisfied and ask the user to enter proper input. Now, in order to perform multiplication of 2 matrices, let us take 2 matrices, matrix A and matrix B. Okay, now if at all I have to perform multiplication on A and B, the condition is that if this is of order m cross n and if this is of order p cross q, the condition is that the column of the first matrix should be equal to the row of the second matrix, that is n should be equal to p. This is the condition to be checked in order to perform matrix multiplication. Okay, now if this condition is not satisfied, then we have to ask the user to enter appropriate matrices. Okay, the next one is to read the matrix, and finally we have to perform matrix multiplication and print the result along with the output matrix. How are we going to perform matrix multiplication? A quick review on the same. 3, 4. I'll take the same elements 1, 2, 3, 4. It's not element by wise multiplication, it's slightly different. You go through rows and you go through columns in the second matrix. So how is that multiplication done? So it is something like this: 1 into 1 plus 2 into 3. Okay, right? Same thing. 3, second column, 1 into 2 plus 2 into 4. 3 into 1 plus 4 into 3, 3 into 2 plus 4 into 4. This is how we perform matrix multiplication. What does this results to? This will results to 7, 10, 15, 20. Observe here, what are we doing? We are taking the first element, multiplying it with the first element of, zeroth column, zeroth row element, and first row and zeroth column element, that is row wise and column wise. This is how the processing takes place in order to perform matrix multiplication. Okay, so we have to perform this multiplication. We have to write the code to perform this multiplication, and then we have to print the result. We'll have a look at the code. Okay, so here observe, matrix A is declared. Right. Matrix A of size 10 cross 10, matrix B of 10 cross 10, result of size 10 cross 10, row 1, column 1, the order of matrix A, row 2, column 2, order of matrix B. Okay, ask the user to enter the rows and columns of matrix A, row 1 and column 1. Ask the user to enter the order of matrix 2, row 2 and column 2. Now, as I told you before, if matrix A has the order, I'm just writing the same thing again, R1 into C1, R2 into C2. Okay, so the order of matrix 1 is R1 C1, order of matrix B is R2 C2. What is the condition? C1 should be equal to R2. So if it is not equal to R2, I've just put it in a while loop to make sure that the user enters the appropriate value and only then he proceeds further. Okay, you can even have a if statement here and have a return to prevent the user from entering the elements of the matrix. Okay, so just have error, column of first matrix not equal to row of second matrix, re-enter the order of the matrices. Okay, now ask the user to enter the elements of the matrix. In order to read a two-dimensional array, we make use of two for loops because it has two subscripts. Again, I have discussed these things in my video. Have a look at it. So your outer loop ranges from 0 to R1 rows, and then inner loop goes from 0 to column. So how are the elements stored? So it will be stored 0, 1, 2 row wise. If at all you are entering a 3 cross 3 matrices, it will be 0, 1, 2, right? 3, 4, 5, 6, 7, 8. That is, what is the index here? 0, 0, 0, 1, 0, 2. Observe, only J is changing. I is same, which is happening in this loop. Next, this will be 1, 0, 1, 1, 1, 2. Again observe, I is same, J is starting from 0, 1 and 2. It is changing. Here also, it will be 2, 0, 2, 1, 2, 2. Observe, I is same, J is changing from 0, 1 and 2. Okay, the elements are stored row wise. Similarly, read the elements of matrix 2. So this is how we read the elements of matrix 2. Here this is just a interactive statement to enter appropriate element. If you want, you can simply skip it. Okay, if it is confusing for you. Next, there is one more requirement to initialize this result matrix to all 0. So how is it? We are multiplying A and B and we are storing it into result. Okay, A is of order R1 cross C1, B is of order R2 cross C2. Okay, now the resultant matrix will be of order R1 cross C2. This is to check the compatibility. Now this becomes your order of the matrix R. Okay. Yeah, we have to initialize all its elements to 0 because we will be storing a partial result in between a computation of multiplication here. Is this clear? Now finally the core part of multiplication. Yeah, what is that? Multiplying the two matrices. So how does it go? I'll take a small matrix for demonstration purpose. The same thing can be applied for bigger matrix. Okay, so I will take a 2 cross 2 matrix, 1 2 3 1 1 2 4 2. Okay, now R is a resultant matrix which initially has 0. Now what are the variables here? I, j, okay, and k. These are the variables. Initially all are assigned to 0. Okay, and it should range from all 0 to 2. 0 to 2. Okay, now we'll just quickly trace it. For I equal to 0, 0 is less than 2. This can be written as plus plus I or I plus plus, anything is okay. Same thing, j equal to 0, j is less than 2, plus plus j. Now how does this nested for loop work? First the innermost loop is executed. Once the condition becomes false, the control is given to the outer loop. Again the inner loop starts from the beginning. Okay, it is executed, it becomes false. If the outer loop becomes false, it goes to the next outer loop. The condition is checked, incrementation is done and the condition is checked. If it is true, you again start j from first, you start k from first and perform the computation. Okay, we'll just quickly trace it. K equal to 0, k is less than 2, R of, what is that? 0 0 is equal to, so this is a compound assignment, compound plus. Okay, so this will be expanded as R of 0 0 plus A of ik. So initially both are 0 into B of kj. So what is that? 0 0 is 0 plus A of 0 0. I'll just write the index here. 1 1 0 1 1 0 0 0 1 1 0 1 1. 0 0 is 1 into B of 0 0 is 1. So what is the partial result? It is 1. Okay, so that will be stored here. It's a partial result, it's not a final result. I'll just write on top. Now in inner loop is not yet done. Increment the value of k, k becomes 1, k becomes 1, right? Again you have to compute the things. R of 0 0 is equal to R of 0 0. What is there in R of 0 0? It is 1 plus A of 0 1. K is 1 now. 0 1 into B of 1, J is 0. What is A of 0 1? A of 0 1 is 2. See, just observe, we are going row wise for A, column wise for B, into B of 1 0. What is 1 0? Is 4. So this becomes, apply the precedence property. So this becomes 8. To that we add 1. Increment the value of k. K becomes 2. 2 less than 2. Condition becomes false. You come out of this kth loop. So what is the updated value for j? Resultant. So this becomes, I'll just update it here. This is 9. We got our first element. Okay, I'll just clear the things. Okay, so we are done with R. So I'll just erase this R to prevent further confusion. Okay, so we are done with the first element of R now. Okay, now what is the value of J? So this is done. J now becomes 1. J becomes 1. 1 is less than 2. Condition is true. Start from k equal to 0 again. So what happens now? Result of 0, what is J? 1 is equal to A of I is still 0, k is also 0. Okay, this is 0 plus into B of what is k? 0, J is 1. So this becomes 0 plus. So we have to go for the second column now. We have done with the first column. We have to do the second column. A of 0, 0 is 1 into 0, 1 is this element 2. So this becomes 2. This is a partial result. Again, I am writing it here. Finally, we'll write it. Okay. Next, increment the value of k. K becomes 1. 1 is less than 2. Update 0, 1, ij is equal to result plus A of what is that? Ik 0. K becomes 1. K is 1 now into B of k. K is 1. J is also 1. So what is the value? 2 plus A of 0, 1 is 2 into B of 1, 1, 2. Apply the property of precedence. So this is evaluated first. 4 plus 2 is 6. So this is a final value. So 6 is a final value, final result. Right? Increment the value of k. K becomes 2. 2 less than 2. Condition becomes false. Correct? Now, this is done. This loop is done. Go back. Increment the value of j. J becomes 2. 2 less than 2. Again, condition becomes false. Now you go and increment the value of I. I now becomes 1, which is less than 2. Okay? Now, you have to again start it from zeros. Okay? We'll have a look at it. Right? Okay. J is 0, k is also 0. Right? R of I is 1 now, j is 0 is equal to what is 1, 0? 0 plus A of ik, I is 1 now, k is 0 into B of what is k? K is 0, j is 0. So we have to take second row, 0th row and first row. So first row's element, first element, and 0th column, 0th element. So this becomes 0 plus A of 1, 0 is 3 into B of 0, 0 is 1. So this comes out to be 3. Again, this is a partial result. We'll update it later on. R of, increment the k by 1. 1 is less than 2. 1, 0 is equal to 3 plus A of, what is A of ik? I is 1. K is also 1 into B of what is B? K is 1 and J is still 0. Right? So this becomes 3 plus what is 1, 1 is 1 into what is B of 1, 0? B of 1, 0 is 4, which comes out to be 4 plus 3, 7. So this is a final result of this element. Alright, so this becomes 7. Increment k value becomes 2, 2 less than 2, condition becomes false. Correct. So you come out of this kth loop, increment the value of j. j now becomes 1, which is less than 2. So now reiterate again for k equal to 0. From that point you have to start. Okay, so I'll just erase this. Start from 0. A of I is 1, sorry, r of I is 1, j is also 1, is equal to, this element is 0 plus r of 1 1 plus it is, so r of 1 1 is equal to r of 1 1 plus a of 1 0 into b of 0 1, which comes out to be 0 plus, what is 1 0? It is 3 into, what is 0 1 is the second column first element. So this comes out to be 6. Partial result it is. Okay, increment the value of k, becomes 1, 1 is less than 2. So this is r of 1 1 is equal to r of 1 1 plus a of, what is that? I is 1, k is also 1 now, into b of k is 1, and what is j? J is also 1. 6 plus, what is a of 1 1 is 1 into b of 1 1 is 2. So this comes out to be 8. So that is a final fourth element of our result. Okay, so we have computed the resultant matrix. Now what is the last part? The last part is to print the resultant matrix. So how do you print that resultant matrix? Using the for loop. So we have already understood what is the index for this resultant matrix, R1 and C2. Print result. Then after printing first row, you have to go for the second row. So how do you do that? J is equal to C2 minus 1, or instead of this, what you can do is end your for loop here. After that, have a new line character. Okay, so you can have something like this: for I equal to 0, I less than R1, I plus plus. Okay, for j equal to 0, j less than C2 plus plus. Okay, printf percentage d result of ij. Printf, after printing first element, first row, have a new line character, printf \n. You can do this as well. I hope you understood the matrix multiplication. Thank you for watching.